Good afternoon, everyone. Welcome to I²-Maths Academy, where numbers meet mastery. Today, we are going to be looking at the product rule, how to apply the product rule to differentiate two or more functions. Now, when you have the dependent variable y to be equal to uv, where u and v are both functions of x, it means that y plus delta y, that's changing y, is equal to u plus delta u times v plus delta v. Yes, u and v are the independent variables. Y is a dependent variable. So a change in y plus delta y, will lead to a change in u and v. That is u plus delta u and v plus delta v. Now it means here y plus delta y will be equal to, you expand this, we have u times v, uv plus u times delta v is u delta v plus delta u times v is v delta u plus delta u times delta v is delta u delta v. So here, let's look at y plus delta y minus y. Now remember we said the value of y is uv. So it means here we have uv plus u delta v plus v delta u plus delta u delta v minus uv. Because since we are subtracting y from the left hand side, it means in the right hand side we'll subtract uv. So y minus y is gone. I'll be left with delta y to be equal to uv minus uv will go. So here we have u delta v plus v delta u plus delta u delta v. Now let's look at changing y all over changing x. That's delta y all over delta x. That will be equal to u delta v all over delta x plus v delta u all over delta x plus delta u delta v all over delta x. Yes, that's delta y all over delta x. Now, as delta x tends to 0, yes, as delta x tends to 0, it means delta u will tend to 0, delta v will also tend to 0, delta y all over delta x will limit itself to the y all over the x, delta v all over delta x will limit itself to the v all over the x, and delta u all over delta x will limit itself to the u all over the x. So it therefore means that the value of the y all over the x, the y all over the x will be equal to, here we have u the v all over the x plus, here we have v the u all over the x plus delta u, and here we have the v all over the x. And remember we said that as delta x tends to 0, delta u tends to 0, and delta v also tends to 0. It therefore means that the y all over the x will be equal to u the v all over the x plus v the u all over the x plus 0 times the v all over the x. And of course, we all know that 0 times any value is equal to 0. It therefore means that 0 times the v all over the x will give us 0. So therefore, the y all over the x will be equal to u the v all over the x plus v the u all over the x plus 0. So it therefore means that the y all over the x will be equal to, now since this is addition, and we all know that the relationship in addition is commutative, it means you can start with this or this. 5 plus 2 is the same thing as 2 plus 5. So it means I can say the y dx is equal to v the u all over dx plus u the v all over dx. So it therefore means that if y is equal to uv, the y all over the x will be equal to v the u all over the x plus u the v all over the x. So this is called the product rule. Yes, this is called the product rule. Now we are going to be looking at an example where we're going to be applying the product rule. Now let's call it example 1. Example 1. Example 1. If y is equal to x raised to the power of 3 sine x, find the y all over the x. Yes, if y is equal to x raised to the power of 3 sine x, find the y all over the x. Now, in this case, we have seen that x power 3 and sine x, they are products of a function. So it means that here we can say let u be equal to x power 3 and v be equal to sine x. Now, the u all over the x, when you differentiate x power 3, it gives 3x raised to the power of 2. And the v all over the x, when you differentiate sine x, it gives cos x. Yes, the standard derivative of sine x is cos x. And remember we said if y is equal to uv, that the y all over the x will be equal to v the u all over the x plus u the v all over the x. So it means in this case, where y is equal to x raised to the power of 3 sine x, the y all over the x will be equal to, you pick v first. And remember we said let v be equal to sine x. So you pick your v, which is sine x. Now you bring the value of the u all over the x. And if you look at this here, we said the u dx is 3x squared. So here we have 3x squared. Plus, you pick the value of u. Our u is x raised to the power of 3. So here we have x raised to the power of 3. Then the v all over the x. The v all over the x give us cos x. So here we have cos x. So it means the y all over the x will be equal to, if you multiply sine x times 3x squared, it will give 3x squared sine x. Plus, when you multiply x power 3 times cos x, it gives x power 3 cos x. So therefore, the y all over the x will be equal to 3x squared sine x plus, we have x raised to the power of 3 cos x. Now, if you look at this function very closely, you will discover that here x squared is common, because here we have x squared and here we have x raised to the power of 3. So it means the y all over the x, the y all over the x will be equal to, you take x squared, you factor x squared out. So here you have 3 sine x plus, out of this x power 3 is outside. So we'll be left with x. Then we have cos x. So thank you. So that is the value of our the y all over the x. So please, we're going to watch out for more examples using the product rule. Thank you.